So we're just going to do this first part of notes 47. So it's going to be really fast. Really just this page and this little chart down here. It's just the characteristics of acids and bases. So really fast. Here we go. It'll just help us not have to do as much tomorrow. So you have time in a class period to finish your assignment for tomorrow. So characteristics of acids and bases. For one, let's just kind of say what an acid and base is real fast. So an acid is something that has a pH, so has a pH that is less than 7, and a base is something that has a pH more than 7. And we're kind of giving you some characteristics. You can kind of start thinking of what these things might be in your head. So acids tend to taste sour. Okay, they react with metals to produce a hydrogen gas. So if I pour acids, different types of acids, onto metal, they produce little bubbles of hydrogen gas. They react with carbonates to produce carbon dioxide. So again, if I pour them something with carbonate in it, they produce carbon dioxide. So that's an example of like vinegar is a common acid. And when you pour it on baking soda is sodium bicarbonate. So sodium bicarbonate. So it has that keyword carbonate. When you pour vinegar onto baking soda, what happens? Remember, that's like a volcano. Vinegar and baking soda, the little science experiment volcano, so it goes with bubbles. So that's the production of carbon dioxide. The effect indicator, so these are things that we could test. We could test some substances in the lab, and with these tests, it would tell us if it's an acid or a base. Or just neutral. So if it's an acid, it's going to turn blue litmus paper. It's going to turn it red. It's going to remain clear with the adding of phenolphthalein. So phenolphthalein is a base indicator. It will turn hot pink in the presence of a base, but won't do anything with an acid. So it's going to stay clear with phenolphthalein. They have pH values that are less than 7. So the pH, let's just kind of put pH up here. So pH is 0 to 14. Those are our indicators. And in the middle, 7 is neutral. And over here is acid. So anything this way is an acid, and anything this way is a base. We'll talk about more like what makes it have that, like why is it a base, why is it an acid. But it has a pH less than 7, has a pH more than 7 is a base. Acids can cause severe burns. I marked it out and underlined it. Okay, so acids can cause severe burns. Now, the reason why they are an acid is they react to have hydrogen plus ions. They actually have H plus ions, so hydrogen with a positive charge, so with more protons than it has electrons. So hydrogen with a positive charge floating around in it, that's what makes it an acid. The more H plus it has, the stronger of an acid it is. So number 8 says have formulas. In general, that begin with H. So how do I know what they look like? In a compound formula is acids are always written with hydrogen to start. So if you see that H in front of the rest of the compound, there's not always, but that certainly is a chance it's an acid if it has a hydrogen in front. Because again, remember, what makes it an acid is it has H plus ions in it. So it obviously has to have H in it, and the H is written first. All right. There's some terms. So the Arrhenius acids are substances that produce hydrogen ions when dissolved in water. So that's just a vocab term to know. An Arrhenius acid is a substance that produces those H plus ions, those hydrogen ions, when dissolved in water. So if it produces those when dissolved in water, it's an Arrhenius acid. Whereas a Bronsted-Lowry acid is a substance that produces hydrogen ions or are proton donors. So it just means that they're going to trade hydrogens in a different way. And they're going to do it with different substances. So this is just in water. This is going to give protons away. So instead of like, this is just going to create it, this is going to give protons away. But it's just terms. Basically, just as long as you have your notes and you have your terms, you'll be okay. All right, so now for the indicator, it says indicator substance is, an indicator is a substance which changes color to tell me if it's an acid or base. So anytime I say a pH indicator, it's just telling me if it's an acid or a base based on the color it turns. So like the blue litmus paper turns red in the presence of an acid. The pH of a base can be determined by phenolphthalein, it turns pink in the presence of a base. So anything that changes color, that tells me if it's an acid or a base is called an indicator. All right, so we're gonna do that same thing and go through some base characteristics. So if it's a base, meaning it's above 7 in the pH scale. Water, by the way, just so you have a reference, water is not acidic or basic. Water is neutral, so it's right on 7. So base, any bases tend to taste bitter. It's got a bitter taste. They feel slippery to the touch. A lot of our common bases are types of soaps. I don't know if you've ever had soap in your mouth that is bitter. Effect indicators. So what are some indicators? If I use red litmus paper, it will turn blue in the presence of a base. And it will turn hot pink, like I said up there, it will turn hot pink with phenolphthalein, okay? They have pH values that are greater than 7. So our pH chart up at the top, it's anything bigger than 7 to 14. They also can cause severe burn. So a lot of times I feel like we think of acids as being the scary thing. A strong base is just as scary. And honestly, you have more access to strong bases in your life, strong cleaning solutions that could cause burns if left on you. You have more chances to be around that than you do around strong acids. They react to produce hydroxide ions. So what makes a base is that it has these OH negative ions floating around it. And the more OH negative ions it has, the more basic that substance is. So when I'm looking for them in a formula, in a chemical formula, well, I'm going to see that OH. I'm going to see that OH and it's going to be at the end. So bases have OH negative ions floating around in them. So I'm going to see that in the formula. That's going to tell me it's a base, not an acid. Now for the same thing, we just kind of have some terms. So you just have them. So the Arrhenius bases, substances that produce hydroxide. So hydroxide is this OH, okay? So it's going to produce that hydroxide ions and dissolve in water. Whereas a Bronsted-Lowry base is substances that produce hydroxide ions for our proton acceptor. So they're like the ones above that we're giving protons away. These are going to take protons if it's a Bronsted-Lowry base, or it's just going to produce the ions in water, and that's an Arrhenius base. All right, so last thing to go over. So we have acids, bases, and salts. So a salt, and oh, by the way, all of these are electrolytes. So that was up above with our water. With our water notes, that electrolytes are things that can conduct a current through it. Even a liquid state can conduct a current, and acids and bases both do that, as well as salts. So a salt, I love to think of salt like table salt, like we eat it. It's not just that. Table salt is a salt, but it's just one type of salt that we have just generically called salt, even though really it's sodium chloride. Anything that is an ionic compound, if it's an ionic compound, it is a salt, okay? So that just means it has a metal and a non-metal. So if you see a metal and a non-metal, it's a salt. It could also have ammonium and a non-metal because ammonium is positive. So it just means a positive thing with a negative thing bonded together ionically. That is a salt. So like NaCl, which is a table salt, well, sodium is a metal, chlorine is a non-metal. And that is what actually makes it a salt, is the fact it's a metal with a non-metal. It just happens to be the one that we eat. But anything that's a metal and a non-metal is a salt. All right, so all we're gonna do is fill out this chart with a couple examples of like household items that are acids and bases, just to kind of give you a frame of reference of things you could identify with in your home. And then we'll stop. So up here, some acids that should be commonly found in your house would be like vinegar is an acid, has those floating H+ ions. Anything that's a clear soda, like Sprite, okay, any kind of clear soda. Milk, which actually is weird. I don't think of milk being acidic at all, but it actually is on the acidic side, just barely. And then bases, so some common bases found in your house would be dish soap, baking soda, just sodium bicarbonate, and bleach. So basically cleaning products. When you think cleaning products, you should think it's basic. And some common salts, obviously we have table salt. So that's NaCl, right? If you have Epsom salt, I forget what's magnesium sulfate, I'm pretty sure. So magnesium is a metal, sulfate is non-metal, when it has a compound of non-metals. And then actually, baking soda doubles. So baking soda is a base. It has basic properties, meaning it has a higher pH of 7 or above, but it also is a salt, meaning that baking soda is sodium bicarbonate. So that is in a bicarbonate. I forget its whole formula, but it's something with C. So that's our metal, that's our non-metal. So that's an ionic compound. So baking soda is a salt, actually. Not a salt that we eat like we eat table salt, but it still is considered a salt, an electrolyte that conducts electricity. Okay, so that is where we're going to stop for today and just take your test. The test is pretty short. That's why I added this in today.